In this experiment, we're going to carry out some microscale electrolysis. We're using this simple setup. A battery is connected to two carbon fibre electrodes. Carbon fibre is used in preference to graphite as it is far less likely to break. These electrodes are simply dipped into a solution and we see what happens. In this first experiment, we're using a solution of potassium iodide, which also contains some starch solution. When the solution is electrolyzed, iodine is produced, and you can see the dark blue-black complex it forms with the starch. Next, we try potassium bromide. With no dark starch complex formed, the change is a little more subtle, but you can clearly see a yellow colour forming around one of the electrodes. This is bromine. Now, sodium sulfate with some blue dye in. You can see bubbles appearing at both electrodes. In this case we're getting hydrogen and oxygen. In theory the blue dye should be unaffected, however you may see, as here, a slight fading round one of them. This is almost certainly due to the bleaching effect of ozone, a small amount of which can be produced in the electrolysis process. Now we carry out a similar process using sodium chloride and blue dye. In this case you can easily see a clear patch forming around one of the electrodes. This time the dye is definitely being bleached, and by chlorine. You may be able to smell it as well. Now we'll look at indicators. The suggestion in the instructions is to use sodium chloride, but you may be better off using the sodium sulfate. We're using phenolphthalein. And this time, when you electrolyse the solution, you see a purple colour appearing in the solution due to the presence of the hydroxide ions changing the colour of the indicator. A more effective version is to use sodium sulfate with some universal indicator. This time you can clearly see a red colour appearing at one electrode due to the hydrogen ions and a purple colour at the other due to the hydroxide ions. Finally, we'll look at a solution of copper chloride. This time, bubbles of chlorine are produced at one electrode. Again, you may be able to smell it. And you should also start to see a deposit appearing at the other electrode. At first it looks black, but after a while, when there is enough, you should be able to see the red-brown colour of copper metal.